Imagine standing at the edge of the Pacific Ocean, the largest and deepest of all the world's oceans. The salty breeze brushes your skin, and the rhythmic crash of waves fills your ears. Before you, the endless blue stretches beyond the horizon, a vast expanse that has inspired awe, curiosity, and even fear for generations. Have you ever wondered what secrets are hidden beneath that shimmering surface? As we slip beneath the waves, we enter a hidden universe, one more mysterious than any place on land. Just below the surface, sunlight dances through the water, illuminating clouds of plankton, the tiny organisms that form the foundation of the ocean's food web. Here, life is abundant and vibrant. But as we descend, the world transforms. The Pacific is the greatest wilderness on Earth, not on land but hidden beneath miles of water. Its surface may seem calm, but below it teems with life. Massive schools of fish move as one, while dolphins and whales traverse vast distances, guided by ancient instincts and the pull of the currents. Covering more than a third of our planet, the Pacific stretches from the icy coasts of Alaska to the tropical islands of the South Pacific, and from Asia to the Americas. Its depths plunge nearly 7 miles down, deeper than Mount Everest is tall. The Mariana Trench, the ocean's deepest point, is a place so remote and extreme that only a handful of humans have ever visited. Despite our most advanced technology, over 80% of this underwater world remains unexplored. The ocean floor is a landscape of towering mountains, deep valleys, and vast plains, most of it mapped only by sonar, its secrets still waiting to be uncovered. Our robotic explorers and submersibles are just beginning to scratch the surface of this alien world. As we journey deeper, sunlight fades and the water grows cold. The vibrant colours of the shallows give way to an inky darkness, a world where pressure is immense and temperatures can drop near freezing. Yet even here life finds a way, adapting to survive in conditions that would be impossible on land. In this eternal night, creatures have evolved to create their own light. Bioluminescent jellyfish drift like living lanterns, while deep-sea fish flash dazzling displays to attract prey or communicate in the darkness. Some species can even turn invisible, blending perfectly with the black water to evade predators. Scattered across the ocean floor, ancient relics rest in silence. Shipwrecks, lost to storms and war, lie preserved for centuries by the cold, dark water. Each artifact tells a story of daring explorers, tragic disasters, and civilizations long forgotten, waiting for their secrets to be revealed. In the deepest abyss, entire ecosystems thrive on chemical energy from the Earth's core. Around hydrothermal vents, bizarre creatures, giant tube worms, blind shrimp, and heat-loving bacteria form oases of life, surviving without sunlight in a world powered by volcanic heat and minerals. The Pacific is not just a vast body of water, it is a living force, shaping our climate and sustaining life on Earth. Its powerful currents act as the planet's circulatory system, transporting heat, nutrients, and life across thousands of miles. These currents connect distant shores, influence weather patterns, and even help regulate the planet's temperature. As we peel back the layers of this great ocean, we're not just exploring a physical space, we're delving into the resilience of life itself. From the tiniest plankton to the largest whales, every creature here is a testament to the ingenuity of adaptation and the enduring mysteries of our own world. The adventure into the deep is an adventure into the unknown heart of our planet. With every descent, every new discovery, we come closer to understanding the wonders that lie beneath the waves and to realizing how much more there is still to explore. The Pacific's hidden depths invite us to dream, to question, and to marvel at the world beneath the waves. Our descent begins into the mesopelagic, or twilight zone, a mysterious region of the ocean where the familiar rules of daylight no longer apply. Here we leave behind the sunlit surface, entering a world where light is a memory and darkness slowly takes hold. This zone starts around 200 meters deep, where sunlight can no longer fully penetrate the water. The world above begins to fade away, replaced by a dim, shifting boundary between day and night. The transition is gradual, colours drain from the water, and the vibrant blues and greens of the surface dissolve into a muted, shadowy palette. Here, sunlight fades to a perpetual blue dusk, casting everything in a dim, ethereal glow. Vision is pushed to its limits and colours disappear, leaving only shades of blue and grey. For marine life, this fading light is both a challenge and an opportunity. Life adapts to scarcity. Creatures have soft, gelatinous bodies and enormous upward-facing eyes to catch the faintest glimmer. Some even produce their own light through bioluminescence, creating brief flashes in the darkness. These adaptations are not just for survival, they are the result of millions of years of evolution, fine-tuned to the unique demands of this twilight world. The barrel-eye fish, with its transparent head and tubular eyes, is perfectly designed to spot prey above while remaining nearly invisible itself. Its eyes can rotate, allowing it to track both predators and prey in the dim light, a remarkable adaptation to the perpetual dusk. And the mysterious vampire squid, with its cloak-like arms and glowing tips, drifts silently through the gloom. It is a master of survival, using bioluminescent displays to confuse predators and communicate in the darkness. In the twilight zone, light becomes a language, a tool for both hunting and hiding. These and countless other creatures thrive in this shadowy world, each uniquely adapted to the challenges of darkness and pressure. The scarcity of light means that every adaptation, whether for seeing, hiding or finding food, can mean the difference between life and death. Every night, billions of small fish, squid and crustaceans rise from the depths in a massive migration to the surface, to feed under the cover of darkness, avoiding predators above. This nightly journey, known as diel vertical migration, is the largest animal migration on Earth, both in scale and in impact. As dawn approaches, they retreat once more to the safety of the gloom, vanishing into the depths before the sun returns. This daily rhythm shapes the lives of countless species, both in the twilight zone and above. This daily vertical migration is the largest on the planet, transporting nutrients and carbon from the surface to the deep, fueling life far below. Scientists study this process to understand how the ocean stores carbon, regulates climate, and supports global food webs. The twilight zone is a critical link in the ocean's food web, connecting the sunlit world above with the mysteries below and supporting countless species. It acts as a vast conveyor belt, moving energy and nutrients through the ocean's layers. It's a world of constant movement where survival depends on adaptation, timing, and the ability to sense even the slightest change in the environment. The creatures here are finely attuned to the rhythms of light and darkness, responding to subtle cues that signal when to rise, when to hide, and when to hunt. Here, the ocean pulses with life, even in the absence of light, as creatures communicate, hunt, and hide in the endless twilight. The interplay of biology, chemistry, and physics in this zone is a frontier of scientific discovery, revealing new species and unexpected behaviours with every expedition. The twilight zone's hidden rhythms sustain the deep and shape the entire ocean ecosystem, influencing life from the surface to the abyss. Understanding this zone is crucial for predicting how the ocean responds to climate change and human impact. In this realm, every photon and every movement matters, and survival is a delicate dance in the shadows of the deep. The twilight zone remains one of the least explored and most scientifically significant regions on our planet, a place where the boundaries between light and darkness, life and mystery, are constantly shifting. Descending into the midnight zone, we find ourselves enveloped in total darkness, an environment so deep that sunlight never reaches it. Yet against all odds, this world is alive with light. Here, bioluminescence is not just a spectacle, it's a way of life. Bioluminescence transforms the blackness into a living cosmos as creatures flash, glow and shimmer in mesmerizing displays. Over 90% of animals in the deep sea are believed to produce their own light. The anglerfish dangles a luminous lure, using its glowing appendage to attract unsuspecting prey in the pitch-black water. Jellyfish pulse with gentle light, creating ethereal patterns that can startle predators or communicate with others of their kind. Some squid release clouds of glowing ink, a dazzling distraction that confuses predators and allows for a quick escape. Even bacteria glow, living in symbiosis with larger animals. The Hawaiian bobtail squid, for example, houses bioluminescent bacteria in its body, using their light to camouflage itself from predators below. Bioluminescence is a tool for survival, attracting mates with intricate light shows, luring prey into striking distance, or confusing attackers with sudden bursts of brightness. The flashlight fish, for instance, uses light organs beneath its eyes to communicate and hunt in the dark. This natural light show is more than beautiful. It's a language and a lifeline in the deep. Some species even synchronize their flashes, creating waves of light that ripple through the water. Scientists study these chemical reactions to inspire new technologies, from medical imaging to glowing crops. The enzymes and proteins responsible for bioluminescence have become invaluable tools in genetic research and disease detection. The green fluorescent protein, discovered in a jellyfish, has already revolutionized biomedical research, allowing scientists to track cells and visualize processes inside living organisms. The secrets of bioluminescence could illuminate our future, inspiring everything from sustainable lighting to advanced medical diagnostics, all sparked by the mysterious glow of the deep. The deep Pacific is a silent museum, preserving shipwrecks lost to storms, war and exploration. But beneath this stillness, the abyss is alive with mysterious sounds, strange echoes and unexplained phenomena that have puzzled scientists for decades. In the cold, dark depths, artifacts survive for centuries, time capsules of human ambition and tragedy. Yet it's not just relics that linger here. Recordings have captured eerie noises like the bloop, Julia and upsweep, enigmatic sounds whose origins remain debated. Some scientists believe these sounds may come from massive icebergs fracturing, underwater volcanic activity, or even undiscovered marine life. Each theory adds to the intrigue, making the abyss a frontier of both history and mystery. Advanced technology like sonar and remotely operated vehicles lets us explore these sites and listen to the ocean's hidden symphony without disturbing it. Each discovery, whether a sunken ship or a new sound, adds to our understanding of maritime history and the ocean's secrets. From ancient voyages to epic naval battles, and from ghostly wrecks to the haunting calls of the deep, the Pacific floor is a library of human history and natural wonder waiting to be read and heard. Discovering a shipwreck is more than an adventure. It's a profound responsibility that connects us to the past and to cultures across the world. These sites are not just collections of artifacts. They are silent graves, cultural time capsules, and irreplaceable treasures that tell the stories of those who came before us. When objects are removed or disturbed, we lose vital context. Fragments of history are erased, and the stories they hold may be lost forever. International laws and agreements like UNESCO's Convention on the Protection of the Underwater Cultural Heritage strive to safeguard these sites. Yet enforcing these protections across the vast open ocean remains a daunting challenge. Around the globe, dedicated teams are pioneering new ways to preserve underwater heritage. Using advanced technology, they create detailed virtual replicas, allowing researchers and the public to explore shipwrecks without disturbing them. Stories of preservation abound, from archaeologists who document every detail before leaving a site untouched, to communities rallying to protect local wrecks from looting. The debate between commercial salvage and archaeological preservation continues, but more voices are calling for knowledge and respect to take precedence over profit. The true treasure of these sites lies not in gold or jewels, but in the stories, information and connections they offer to humanity's shared journey. Across continents, global efforts are growing. Scientists, divers and local communities are working together, using non-invasive methods and sharing knowledge to ensure these underwater witnesses to history are protected for all. It is our collective duty to respect, preserve and share these wonders, so that future generations can learn from and be inspired by the silent stories resting beneath the waves. In 1977, scientists made a groundbreaking discovery on the ocean floor. Hydrothermal vents, fissures that release superheated, mineral-laden water into the frigid depths. These vents, often called black smokers, create a dramatic contrast between the scalding water and the icy ocean around them. Against all odds, these toxic environments teem with life. Giant tube worms, white crabs, mussels, shrimp and even ghostly fish thrive here, forming dense communities around the vents. Each species has evolved remarkable ways to survive the extreme heat, crushing pressure and toxic chemicals. Tube worms, for example, have no mouth or digestive system. Instead, they rely on a unique partnership with bacteria living inside them. These bacteria use chemosynthesis to convert hydrogen sulfide and other chemicals from the vent water into food, sustaining the worms in total darkness. Unlike most life on Earth, which depends on sunlight, these ecosystems are powered entirely by the Earth's internal heat and chemical energy. The vents create a unique food web, with bacteria at its base, supporting a variety of specialized animals. Life here is self-contained, thriving in isolation from the rest of the ocean. Many vent creatures have developed adaptations like heat-resistant proteins, specialized gills, and symbiotic relationships to survive in this harsh, chemical-rich world. The discovery of these extraordinary ecosystems has profound implications. It suggests that life could exist in similar environments elsewhere in our solar system, such as the subsurface oceans of Europa or Enceladus, where hydrothermal activity may also occur. Hydrothermal vents may even hold clues to the origin of life on Earth. Their protected, energy-rich environments could have provided a crucible for the first cells, sparking the earliest forms of life billions of years ago. These deep-sea oases challenge our understanding of where and how life can exist. Scientists continue to study them, searching for new species and unraveling the secrets of their survival. The vents are a testament to life's resilience in the most unlikely places, revealing the astonishing adaptability of organisms and expanding our view of what it means to be alive. Creatures at hydrothermal vents are masters of adaptation, thriving in extreme heat, pressure and toxicity. Their resilience teaches us about survival in the harshest environments, pushing the boundaries of what we once thought possible for life on Earth. Tube worms' unique hemoglobin transports toxic hydrogen sulfide safely, inspiring new medical research. This remarkable adaptation is guiding scientists in developing advanced blood substitutes and treatments for conditions where oxygen is scarce. Extremophile bacteria have enzymes that function under intense conditions, now used in industry and biotechnology. These enzymes are revolutionizing processes from DNA replication in forensic science to the creation of more efficient biofuels. These microbes are a resource for new medicines and technologies, with some producing anti-cancer compounds. The deep ocean is a wellspring of untapped pharmaceutical potential, offering hope for treatments against diseases that challenge us today. Studying these ecosystems expands our search for life beyond Earth. Sunlight isn't required, only water and chemical energy. This realization has transformed our approach to astrobiology, fueling missions to icy moons and distant planets. The deep sea's strange life forms are analogues for potential extraterrestrial organisms. Their bizarre adaptations challenge our imagination and redefine the limits of biology. These habitats are a library of biological solutions forged over millions of years. Each specimen holds clues to solving problems in medicine, engineering, and environmental science. As we explore, we're not just cataloguing oddities, we're uncovering secrets that may help humanity survive. Deep-sea robotics and submersibles developed to withstand crushing pressures are now influencing the design of spacecraft and remote exploration vehicles. The lessons from the deep could shape our future on this planet and beyond. By embracing the innovations and wisdom hidden beneath the waves, we expand our technological horizons and deepen our understanding of life's resilience, preparing us for challenges yet to come. The vast, remote depths of the Pacific once seemed untouchable, mysterious worlds beyond the reach of human hands. But today, even these hidden realms are under threat from our actions. Deep-sea mining, driven by the demand for valuable minerals, is carving scars into the ocean floor. These fragile habitats, home to life forms we're only beginning to discover, risk being destroyed before we even understand their secrets. Sediment plumes from mining operations can smother entire ecosystems, choking out life and disrupting delicate balances. Recovery from such damage could take centuries, if it happens at all. Plastic pollution has seeped into the deepest trenches, entangling creatures and introducing toxic chemicals into the food web. No corner of the ocean is truly safe. Climate change is warming and acidifying the deep ocean, threatening shell-building organisms and altering the chemistry of these ancient waters. The very foundation of deep-sea life is at risk. The deep sea, once a pristine sanctuary, has become the final resting place for our waste, out of sight, but never out of consequence. We are altering the ocean's fundamental conditions, its temperature, chemistry, and currents, with consequences we can barely predict. The fate of countless species, and perhaps our own, hangs in the balance. But there is hope. By acting now, supporting marine protected areas, reducing pollution, and demanding responsible stewardship, we can safeguard these hidden realms. The mysteries of the deep Pacific are not yet lost, but their future depends on us. The time to protect them is now. The deep Pacific is vital to our planet's life support system, regulating climate, supporting countless species, and providing resources for millions of people. Its currents connect continents, its depths cradle ancient mysteries, and its surface reflects the ever-changing sky. Protecting this immense blue heart is a global challenge, one that demands urgent attention, unwavering hope, and collective action from every corner of the world. Exploration is the first step. We can't protect what we don't know. Every new discovery, from unknown species to hidden underwater landscapes, helps us understand the ocean's complexity and vulnerability. Brave explorers and scientists like Dr. Sylvia Earle and countless unnamed researchers have dedicated their lives to unveiling the Pacific's secrets, inspiring us to look deeper and care more. Marine protected areas like national parks for the ocean can safeguard unique ecosystems from exploitation. These sanctuaries allow marine life to recover and thrive, ensuring biodiversity for future generations. In places like the Phoenix Islands Protected Area, local communities and global partners have come together to restore coral reefs and revive fish populations, proving that hope and action can heal even the most fragile environments. International cooperation is essential, especially in the high seas beyond national borders. Only by working together can we create effective policies and share knowledge to protect these vast waters. Stories of collaboration, like the global effort to ban deep-sea trawling in vulnerable areas, show that when nations unite, the ocean's future brightens. As individuals, our choices matter. Reducing plastic use, choosing sustainable seafood and supporting ocean conservation all make a difference. Small actions multiplied by millions can have a huge impact. Across the Pacific, volunteers have removed tons of plastic from beaches, and communities have shifted to sustainable fishing, proving that everyday guardianship is powerful. Education and advocacy foster a culture of stewardship for the ocean's wonders. By inspiring curiosity and responsibility, we empower communities to protect what they love. In Fiji, young students learn to monitor coral health, while in California, advocates rally for cleaner coasts, each story a testament to the ripple effect of knowledge and passion. The Pacific's depths hold the secrets of our past and the key to our future. From ancient shipwrecks to new forms of life, these mysteries remind us of how much we still have to learn. Each discovery, like the glowing bioluminescent creatures found in the Mariana Trench, sparks wonder and reminds us that the ocean's story is still being written. We stand at a crossroads, with the power to explore or destroy. Our decisions today will shape the fate of the ocean for centuries. Around the world, communities are choosing restoration over exploitation, turning the tide towards a healthier, more resilient Pacific. Let's choose curiosity, respect and care, preserving the mysteries of the deep for generations to come. From families planting mangroves to divers rescuing sea turtles, the guardians of the blue planet are everywhere, each act of kindness a beacon of hope. The health of the deep ocean is tied to the health of our planet. Every ecosystem is connected, and protecting the ocean means protecting ourselves. When we restore coral gardens or safeguard mangrove forests, we build a future where both people and nature thrive. Its protection is our shared responsibility, and together we can be true guardians of the blue planet. Imagine a future where the Pacific's wonders endure, where every child can marvel at its beauty, and where humanity stands united in hope and stewardship. The story of the ocean is ours to write. Let's make it one of resilience, discovery, and lasting guardianship. Beneath the vast blue expanse lies a world few have ever glimpsed, the Pacific's oceanic trenches. Among them, the Mariana Trench stands as the deepest part of our planet's sea floor, plunging nearly 7 miles beneath the waves. These trenches are formed where massive tectonic plates collide, forcing one beneath the other and carving out underwater canyons that dwarf any found on land. Down here, sunlight never penetrates. Temperatures hover just above freezing, and pressures soar to over 1,000 times what we experience at sea level. Yet life endures. In these crushing depths, ghostly amphipods, transparent snailfish, and bizarre microbes thrive, adapting to conditions more alien than those on distant planets. Some creatures glow with their own light, while others survive by feeding on nutrients that drift down from above or by harnessing chemicals seeping from the seafloor. Exploring these trenches is one of science's greatest challenges. Only a handful of submersibles have ever reached the bottom, braving darkness, cold, and immense pressure to capture fleeting glimpses of a realm untouched by sunlight. Each expedition uncovers new species and geological wonders, proof that the Pacific's secrets run deeper than we can imagine. The trenches remind us how much we still have to learn, and how fragile these unexplored places may be. As technology advances, so does our responsibility to explore with care, respecting the mysteries of the deep. The story of the Pacific's trenches is still being written, one dive, one discovery at a time. The Pacific Ocean is a realm of wonder and resilience, but it is not untouched by the hands of humanity. Across its vast expanse, echoes of our presence are impossible to ignore. Plastic debris drifts on the currents, forming islands of waste that threaten marine life at every level. Overfishing has emptied once teeming waters, pushing iconic species to the brink. Climate change warms the seas, bleaches vibrant reefs, and alters the delicate balance that life in the Pacific depends on. But even as these challenges grow, so too does the movement to heal what's been harmed. Scientists and local communities are rising as stewards of the sea. Innovative restoration projects like planting new coral nurseries and developing biodegradable alternatives to plastic are giving hope to damaged ecosystems. In coastal villages, fishers are reviving ancient sustainable practices, working with nature rather than against it. Grassroots conservation efforts are spreading across island nations, empowering people to protect their marine heritage. From creating vast marine protected areas to organising beach cleanups and citizen science dives, these initiatives are rewriting the Pacific story. They remind us that the ocean's future is not yet decided, and that by working together we can turn the tide. The Pacific has always been a source of life and inspiration. Now it calls on us all to become its guardians, ensuring its wonders endure for generations to come.